In this video lesson, designed specifically for Math 12 students, we're going to give you some reminders about how to use your TI graphing calculator, specifically to help with polynomials, but actually these skills will apply for any other functions that we discuss in this course. The first thing that you need to know how to do is to be able to make a table of values on your TI. You start by entering the equation using the y equals button, and here's the x button so that we can type something along the lines of 2x plus 3. And then you're going to press the second button and then graph so that you see the table of values, and it should look something like this. Go ahead and use your TI to create a table of values for 2x plus 3 before you move on in the video. Once you have your table of values, you can use the up and down arrows to move through the table of values to see any others that you might want. If you want to change what you see on the table, you can push the second button and then the window button to get to your table setup. In the table setup, you can change the start, the first x value that you see, as well as the delta value, what x changes by. So I can take the table of values that we just built and ask the calculator to start at 11 and change the x values by 1/2 now. Now, I'll see some different values on screen. Before you move on in the video, check to make sure that you're comfortable changing the table setup. One really helpful use of tables that you may not have seen before is the ask feature. This lets you quickly figure out the value of y when you know x. Before we move on, pause the video and enter this equation in. When you're ready, go to the table setup. Now we're going to choose ask for the independent variable. This lets you type in an x and have the calculator tell you what y is. You won't see the table of values anymore, only the specific x's that you type in. So when we type in x equal to 3, the calculator tells us that y is equal to 6.48. When x was 11, y was negative 742.9. And when x is 1.26, well, why don't you use your calculator to figure out what that value is now, and we'll check in a moment. Your calculator should tell you that x ends up being about negative 0.21. This feature comes in really handy if we have to find several y values. The next thing that we should be able to do is to graph an equation on our TI. Once again, we're going to enter the equation using the y equals button. Take a moment now and change the equation you've entered to be this quadratic. When you're finished, press graph. We'll get something like this on screen, but you may not see the exact same graph. We'll talk about that in a moment. One of the ways to change what you see on screen is to press the window button and manually change the values of x and y that are shown. So you can choose the minimum and the maximum x value. That is, the smallest value of x and the largest value of x that will show up on the axis system. And likewise, you can change the smallest y and the largest y on the axis system. So right now, our x-axis is moving from 0 to 20, and our y-axis is moving from negative 15 to positive 5. Take a few moments to try changing your window settings to make sure that what you see on screen now matches this graph. All Math 12 students are expected to be able to change the window settings and to choose appropriate window settings. If you're not sure what window settings are appropriate, a good idea is to go look at your table of values. That can give you some hints about where intercepts and where vertices are. If you don't know what window settings to choose, you can try experimenting with the zoom button. There are a few options here that are helpful. Zoom in and zoom out are exactly what they sound like. You'll have to push enter once to choose the command, and enter again to actually zoom in or zoom out, focused around where your cursor is. Probably the most useful zoom to know is zoom standard. This gives you the standard window settings of -10 to +10 for both x and y. It's a good first step if you're trying to fix some strange looking axes. This next skill is particularly important for us. It's often described as finding local maximums or minimums, but we can think of it as finding vertices for our course. To begin with, we enter the equation and graph. You need to make sure that you can see the maximum or minimum on screen. In other words, you can see the vertices. So you might have to change your window before continuing on. Once you can see those vertices, you're going to push second and then the trace button. This brings you to the calculate menu. And based on what kind of vertex you're finding, you'll choose either maximum or minimum and press enter. Now you'll see your graph on screen. You're going to move your cursor to the left edge of the screen using the left arrow. Once your cursor is definitely to the left of that boundary, push enter. After you push enter, you'll see a little black triangle on screen showing us the left edge of where the calculator will look for that vertex. It now asks you for a right edge. You need to move your cursor to the right using the right arrow key until you're definitely past that vertex. You'll see a second black triangle appear on screen. This gives your calculator a skinny little area to look for the vertex. It will give you the option to guess. And this can speed things up, so it's a good idea to try and move your cursor as close to the vertex as possible and push enter. When that happens, your calculator will take a few moments and then give you the coordinates of the vertex. Your calculator is really using a sophisticated guess and check, so sometimes it's a little bit off. We would round these coordinates to be 1 and 4. In order to show your work, you should include a labeled sketch. So the work for finding this vertex would look kind of like this. Here's what I saw on screen. The important piece was right here, so I'll put a nice big dot on it. The calculator gave me coordinates of 1 and 4. And now, just to be really sure that when I go back and look at this work later, I understand what I did, I'm going to make sure to also write down the equation. So what you're expected to do is to show the sketch, put a nice big coordinate on the vertex, write down the coordinates of the vertex, and the equation that you used in your calculator. Now let's talk about finding x-intercepts on your TI. This is kind of helpful because it will double for another strategy. This work doubles up for solving equations graphically as well. For now, let's focus on finding x-intercepts. We're going to start by putting our equation in with the y equals button. But now we'll do something a little bit different. In the y2 spot, the second place to graph an equation, for x-intercepts, enter the equation y equal to 0 and graph. Once you graph, check to make sure that you can see the x-intercepts on screen. If not, you'll have to change your window settings. Once you're ready, we're going to go back to that calculate menu. Remember, we got there by pushing second and then the trace button. This does have an option to find a 0, which is another way to talk about x-intercepts, but it gets a little bit awkward. So we're going to use the intersection. We're going to look for where the original curve meets up with y equals 0. That's where the x-intercepts will be. Once you choose this option, the calculator will show you the graph and ask you about the first curve. You're going to make sure that the equation you see at the top of the screen is the equation that you want to find the intercepts of. Once you push enter, it will ask you for a second curve. Check to make sure this second curve is y equal to 0 and push enter. Lastly, you get to move your cursor around for a guess. This is really important. Because many equations have more than one x-intercept, you have to give the calculator a starting place. So you're going to put your cursor as close to the intercept as you want to find as possible, and again, push enter. When this happens, the calculator will give you the coordinates, just like it did for the vertices. And just like we did using our calculators to find vertices, to show our work, we're going to include a labeled sketch. So we show roughly what the graph looks like on screen. We write down the equation we graphed, nice big coordinate, and the coordinates the calculator gave us. In order to find this other intercept, we're going to repeat the process. We'll use second and trace to get to the calculate menu, choose option 5, an intersection, pick that first curve, the second curve, but then we'll move our guess to be over by the other x-intercept. You'll have to repeat the process as many times as there are x-intercepts. While we're talking about the process, let's talk about using the same strategy to solve other equations. What if I needed to solve an equation like this, where y was equal to positive 1? Well, we're going to take the first piece of the equation before the equal symbol and put it into y1. So y1 will equal that same negative x squared, adding 2x, adding 3, that we've been talking about all along. The other part will go into y2. So now instead of y2 equal to 0, we're going to set y2 equal to positive 1. Once you're ready, go ahead and graph. Your graph on screen will now look something like this. We can use the same process, choosing to calculate an intersection, choosing our first curve and second curve, placing a guess, and now our calculator will tell us that this intersection point is at about negative 0.73 and 1. We'll repeat the process to find this other intersection, and its coordinates are at positive 2.73 and 1. The 1's in the y coordinate we already knew about. That was the y that we originally were talking about. So it's these x values that we're interested in. The two x values give us the solutions to the equation. X is equal to negative 0.73 and x is equal to positive 2.73. So let's put this all together. Taking a look at this cubic equation from our studies in class, we already know a lot before we use the graphing calculator. Press pause and see what you can fill in before continuing on. We can fill a lot in already, but let's use the calculator to find out more. Start by trying to use the table to find the y value when x is equal to 1, when x is equal to 0.5, and when x is equal to 12. Press pause while you do this and continue the video to check your work. If you were successful finding these coordinate points, move on. If not, perhaps you might want to re-watch the piece of the video about using the tables of values. Now try graphing this equation, but change your window settings so that your x-axis is from negative 4 to 4 and your y-axis is from negative 3 to 3. When you're ready, continue the video to check the work. Your graph should look something like this. If not, you might want to check about changing window settings. Now try using this same graph that you have on screen to find the maximum value, or the coordinates of the vertex, in the third quadrant. Press pause. When you're ready, check your work by continuing the video. With our calculators, we find out that the coordinates of this vertex are about negative 0.61 and negative 0.47. Now let's see if you can find the coordinates of the one x-intercept of this curve. Again, pause, and when you're ready, check by continuing the video. This one x-intercept has coordinates of about 0.83 and 0. Now you should be ready to move on and try the practice problems on your handout. If not, rewatch any necessary parts of the video and come in for extra help if you need.